of Pi by, the book was, I read a book, and it was by Peter Beckham and Megan Moore. Okay, so the circle was the first thing that like fascinated the man, and the man saw the circle in the pupils of animals and in people, and in the moon and in the sun. And so okay, so proportions. So the thing about the circle is that they found out that the circumference and the diameter are constant for all circles, and that was what they found to be pi. And so they tried to solve pi for so many years, and this was like a long time ago, even before the wheel. And so yeah. Okay, so the first to really try to solve for pi or use pi as a numerical number were the Babylonians, the Egyptians, and the Bible. And the Babylonians' value for pi was 3 1/8, which was 3.125. And the value for pi for the Egyptians was 3.16049. And the value of pi in the Bible was 3. Okay, so if you start with the Babylonians, or which is Mesopotamia, they were the first real farmers, so they used the wheel in their agriculture, and they had a slight underestimation of pi, which was 3.125. Some other countries that were solving for pi during this time were India, Thailand, China, and Greece. And to start with the Greeks, there were 4 Greek men that tried to solve for pi. The first was Anaxagoras, and he lived from 500 to 428 BC. And he taught something that, or found out something that we all know is like common, but he taught that the reason why the Nile River would swell up is because the snow was melting, and because that just wasn't like something that they knew. He was also imprisoned for other theories about the sun, and in jail he attempted to square the circle, which requires the construction of a square that is equal area to the circle. Okay, so another Greek mathematician was Antiphon, and he enunciated the principle of exhaustion, which pretty much states that that you take a circle, and inside the circle you make a polygon with an n amount of sides, and as the number of sides goes to infinity, the area of this polygon will equal the area of a circle, and it will become a circle pretty much. So it's very similar to if you're taking the area under a curve and you're making an infinite amount of rectangles. So, another Greek was Hippocrates, and he was the first to find the exact area bounded by a curve. In his case, he used circular arcs. And another Greek was Hippias, and he was the first man on record to define a curve that was not a circle or a straight line. So his curve that he found was called a trisectrix, because it could be used to dissect an angle and quadratics. Okay, so as I'm going along, it's kind of just talking about history as it keeps going of math and pi. So next was really the Library of Alexandria, and the library had close to 7,500,000 books, and that was really big back then because the books were all scrolls and they were all handwritten because there wasn't a printing press yet. And math really flourished here, and it wasn't really a library, it was more of an institute or a school. For example, the chief librarian calculated the diameter or the circumference of Earth within 5% accuracy. So just by observing the different places on Earth and knowing their distance between them and finding their distance to the sun, and that's how he solved it. Euclid was a scholar at Alexandria, and he wrote a book called Elements, which is like the 5 basic stepping stones of all geometry. And he is said to be the father of geometry, or not the father of geometry, but the father of a mathematical rigor. He also said that a proof cannot be circular, so what you're trying to prove cannot be used to help prove it. So in other words, it's like the if and only if, and the differences between one and only one is what he really emphasized on. So his 5 foundations was that a straight line may be drawn from any point from one point to another. So no matter where the 2 points are, there can always be a straight line. Another thing that he said is that a finite straight line may be extended continuously through a straight line. So like you just put them up. And another thing is a circle may be described with any center and a radius. So if you think about the way you write an equation for a circle, you need the radius and the center. So that's where that comes from. And another thing was all right angles are equal to each other. So 90 degrees equals 90 degrees equals 90 degrees, and they're all right angles. And the last one was given a line and a point not on that line. So you have a line and a point. There's only one line that can make it that point parallel to that line. So if you put a point going through that line, there's only one. So those were his 5 foundations. And the attitude towards the ancient Greeks, or attitude of the ancient Greeks towards his geometry was essentially like this: is the truth that comes, that the truth of these 5 axioms is obvious, therefore everything that follows is also valid. But now in modern mathematics, it says if we assume that all 5 of these are truthful, then everything that follows has to be valid. So there's like a little bit of a discrepancy now. Moving on to the Romans, they didn't really add or enhance the mathematics during this time period because they were kind of just the capital of thugs, and they didn't really have this critical thinking that they needed. For example, with Roman law, there was a thing that said where there is no patrol car, there is no speed limit, because the Roman Empire was so big, there wasn't really anything like special in anything. And another thing was the Roman roads ran absolutely straight. So if one of them was to go to a mountain, and say the road would have to go over the mountain, it couldn't go around it because they didn't really have that critical thinking that we can just go around it. Another thing about them was that their Roman army camps had to be the same at every single camp. If it was on a hill, they'd have to dig until it was flat so it could reach their old things. They didn't really have that critical thinking to adjust it. And their biggest accomplishment, or I would say like failure during this time, was they burnt down the Library of Alexandria. Okay, so moving on to the Silver Ages, which is after the Golden Ages because the Library of Alexandria had been burnt down, and hence it's not the Golden Age because nothing really happened during this time, and it's kind of on a decline. Archimedes of Syracuse, he was the person that when taking a bath yelled yippee because he realized that when he entered the water level rose, or he yelled eureka, sorry. The water level rose, and he realized that was his volume of himself. He was the first writer who put mathematics and physics together and really like allied them together. And he also said that equal to is arbitrarily close, and it means that it could be as closely defined as, and doesn't have to be like exactly equal, so as the limit goes to a number instead of having to be equal. And he was the first to calculate pi to any degree of accuracy. You can't really see it, but here, I'll draw it. There's a circle right here, and inside the circle there's a polygon, and on the outside of the circle there's a polygon. And he used the sandwich theorem to limit the two to have an infinite amount of sides to be as close to the circle's circumference as possible, or the outside of the circle. And so that's pretty much what he did to solve for his values of pi, and he got it to the closest degree of accuracy that it has been at up until this time. Moving on to the Middle Ages, it became to be a thing that when knowledge was power, and power over the gullible and over the undereducated. During this time, the Pythagorean theorem was created, and so Pythagoras discovered that 3 squared plus 4 squared equals 5 squared, hence x squared plus y squared equals z squared. And also during this time, it became a thing if you would would go down a path of science, or you'd go down a path of like witchcraft and the occult studies. And so people that were in higher or like society didn't really accept scientific facts coming in because they thought that they were solving all these problems by using witchcraft. For example, a Spanish mathematician, Valmes, was burned at the stake because he claimed to have found the solution to the quartic equation. And another example is a Viking escaped Norwegian ships by sailing into the wind by tacking up wind, and because they'd only sailed straight before, or like not sailed directly into the wind, and he thought, or the king of Norway thought that he was using magical powers to sail into the wind. And another example was Galileo, who went through torture chambers for saying that the earth moves around the sun. So science and math was really not appreciated, or was not really appreciated at this time, and they thought it was more like a witchcraft and the whole thing. Okay, so it was soon discovered that pi is not a rational number because it cannot be expressed as a ratio of two integers, so i.e. a rational number. Okay, so these are a whole bunch of names and digit places that pi was discovered to without a computer. And so it got to as far as 248 decimal places without a computer. And it would kind of just became a competition to see who could go the furthest and to see who could solve pi to the greatest degree of accuracy. So Euler found pi to be between these two numbers. And so Euler also said that it appears to be fairly certain that the periphery of a circle constitutes such a peculiar kind of transcendental quantities that in no way it can be compared with any other quantities, either roots or other transcendentals. And Euler was right, but it took another 107 years to prove his conjecture. Okay, so some of you may be saying, what is the transcendence of a number or of pi? And so when you think of a number, you think it's rational or irrational, or algebraic or transcendental. And this question haunted mathematicians for even 107 years after Euler had asked it. And Euclid's geometry says if pi is a transcendental number, then it cannot be squared. And that's the way that they were going at trying to solve the value of pi for a long time. And so overall, it was very hard to prove that these types of numbers existed. And they're not really favored among mathematicians. But another number other than pi for a transcendental number is e. And so, okay, the modern circle squarers, or the Americans. So the race of the this is a quote, that the race of the circle squarers will never die out as long as ignorance and thirst for glory remains united. And so pretty much pi had been, or people kept trying to solve for pi, and people at schools like University of Chicago and Harvard and UPenn all tried to solve for pi, but they couldn't get any further than what had already been solved, because not until the computer came along, because it was already really hard to do it. So then in the computer age, by 1967, pi had been solved to 500,000 different places, or well, 500,000 decimal places. And the first calculation pi was made in the first computer calculation of pi was made in 1949, only to 2,037 places, and it took 70 hours. And so lots of progress was made during this time, and the record was 500,000 decimal places in 28 hours and 10 minutes. And that happened in 1967, and that's still the record. And the things about computers, though, is that every step to produce the result must be like translated by a instruction, and you can't just ask the computer what is the value of pi, or can you solve pi? You have to give it some mathematical formula to execute, and then that's what the value of pi will be. Okay, so the book leaves off on this quote, is that the history of pi is only a small part of the history of mathematics, which itself is but a mirror of the history of a man, or of men. And this is the book that I read. And do you have any questions?
said that pi has something to do with the ratio between the circumference and the diameter.
Uh-huh.
Can you explain that again?
Oh, okay, so, here, I'll bring it back to this one. Okay. Okay, so, like, this is an example, is that the, like, you know ratios, but like 1 to 1/2 equals 2 to 1 equals 3 to 3/2.
Right.
And it's all a constant ratio. So when you take like the circumference to the ratio, or to the a radius or the diameter of a circle, the thing that what do you do when you try to solve for this or the circumference with when you know the radius? It's 2 pi r. And so that is equal to this, or the circumference is related to the diameter because of pi, and so it's always constant throughout.
That makes sense.
That, yeah. Mhm.
So I think nowadays, I forget what the number was, I think it was something like, we have like 10 trillion digits of pi or something, but why would you need that many digits of pi for anything?
I don't.
Significant.
Yeah, I don't really think you would need that many digits because once you're to a certain point of accuracy, you can it like won't really affect your answer. But I think people just want to keep, because it keeps going on and on forever, and people want to keep solving for it. I feel like it's kind of like the unknown, and it's mysterious to people. So, yeah. Okay. That's it.
Yeah.